continue on with interest today, but we're going to be looking at compound interest. So it turns out, and I think I mentioned this last time, that there's two types of interest. The first type of interest we looked at last day. It's simple interest. And simple interest is interest that's based on the principal and the interest rate. Remember, the principal is how much you put into the bank or how much you borrow from the bank. And then the interest rate is a percentage, and the higher percentage, the more interest you're going to make. Remember the formula? It's I equals PRT. P is principal, R is the interest rate, make sure to write as a decimal, and T is time, must be in years. Then you multiply those three things together. Alright, so that's last day. Today we're going to look at compound interest. Compound interest is more common and it's much more powerful. Compound interest is interest which is earned on both the principal and this is the key, you also get interest on the previously earned interest. Okay, this is not the case with simple interest. With simple interest, you get the interest calculated one time and it remains the same no matter how long you leave your investment in the financial institution. So I thought it might be easiest to understand this if we did two different examples. Exactly the same situation, one's Stephen, one's Ryan though. They both invest $10,000 for 5 years. The interest rate in both cases is 4.2. The difference is for this first situation up here, it's going to be a simple interest account, and for Ryan's situation down here, it's going to be compound interest. And I want to know how much would this person have earned after each of the years, and also how much would they earn after all 5 years in total. So we're basically going to fill in this chart here. So the first thing to fill in is what's your balance at the start of the current year. This is year zero. That's like the starting time, right? So the balance at the starting time is $10,000. So I'm going to put 10,000 in here. And I want to figure out how much interest I earned that year. Okay, well, this is simple interest. So for all the questions in this chart, we're going to use I equals P times R times T. So to get the interest, we have to multiply the 10,000, that's our P, the principal, times the interest rate, 4.2. But remember, we're not going to use 4.2. We have to switch it out of this percent form. So you're going to divide it by 100, or you're going to move the decimal over 2 spots. You're going to get 0.042. So that is your R value, 0.042. And I'm just going to see how much I've earned in interest after a single year. So for T time, I'm going to put 1. And if you multiply this all out, you're going to get $420. Okay, that's the interest for the first year. Okay, so what's the balance at the end of the current year? Well, this is like our final amount. Remember how we did that? To get the final amount, which is A, we took the principal and we added the interest. So in this case, we'd be taking our $10,000, that was our principal, and we'd be adding our interest, which is 420. So we'd have $10,420. That's how much Stephen has after 1 year. So at the start of now, 1 year has passed, right? And at the start of this next year, the balance at the end of 1 year is the same as the balance at the start of the current year. So we put 10,420 here as well. Now here's the thing. With simple interest, you see how we calculated this 420 here? That's not going to change. For the rest of the time this money is invested, he always is going to make $420 every single one of these years. So now we can kind of whip through this. Going to go to 10,420, and he makes $420 more this year. So that's going to take him up to 10,840. You're clear how I did that? I just added the 10,420 plus the 420. So the next year he starts with that amount, 10,840. He makes this amount interest the next year. The amount of interest he makes every year stays the same. So we add another 420. That takes him up to 11,260. So that's how much he starts with the next year. Add on another 420 because that's how much he makes every year in simple interest. He's up to 11,680. That's his starting amount for the fourth year. And if we add on our 420 to that, because he always makes 420, ends up at $12,100. It's actually a little hard to understand here. This was the end of the first year, end of the second, end of the third, end of the fourth, end of the fifth. So it's actually the end of the fifth year right here, and that's what we're interested in. So in simple interest, ended up with $12,100. Now, if we only wanted to know that amount right there, we could have used the same formula, right? The I equals PRT. And we could have started with the same principle, which is 10,000. we could have used the same interest rate. Remember, it was 0.042. But if I wanted to know how much he earned after 5 years, instead of going each year one at a time, I could have just multiplied by 5. And if you did that, you would get 2,100. Now, that's not this number. What's going on? Because that's just the interest. If we want to know the actual final amount, that's what this is here, the final amount, of course, we would do our principal plus our interest. So we'd be doing the 10,000 plus the 2,100 in interest, and we'd end up with $12,100, just like we got right here. So let's move on to the compound interest. We're going to do everything the same, remember. The only thing different is it's going to be compound interest, which means you get paid interest on the interest you already earned. Sound confusing? It's actually not that bad. So we can do this example by using the same formula, by using that simple interest formula. We will come up with a better formula in a second for the compound interest, but we can get the idea by using the simple interest formula. So we're starting with the same amount of money. We're putting $10,000 to start in the bank. And to get the interest, it's actually going to be exactly the same for the first one. We're going to do the same thing we did up here, right? We're going to use the simple interest formula. So we're multiplying P, which is 10,000, times R, the interest rate. Well, the interest rate was exactly the same as it was up there, so it's going to be 0.042 when we switch it out of the percent form. And we're going to do this 1 year at a time, so we multiply it by 1, and obviously we're going to get the same answer we got up there. We get $420. So what's our balance at the end of the year? Same as up here. We add our 10,000 and our 420. We get $10,420. So far, nothing's different. Next line. If we ended with 10,420 here, how much do we start here? 10,420. Still the same as right here. So 10,420. Here's where things get different. Remember, up here you always earn 420, 420, 420, 420. That will not be the case here. You have to use this formula again, the I equals PRT, and one thing is different. It's going to be the P is different now. The principal now is not 10,000. You're starting this year with 10,420. So you got to go 10,420. The other numbers will always stay the same. The interest rate is always 0.042. That's a fixed interest rate. And we're doing this 1 year at a time, so we just multiply by 1. And if you do that, you get $437.64. Oh, it's a little bit higher than up here, right? You made an extra $17.64. It's not a huge deal, but hey, it's nice. Okay, to get our new balance, what do? We add this amount with this amount. So we get $10,857.64. Next year we start with that amount, $10,857.64. Wow, I'm not writing very well here. And now we do the same thing, but we're going to put this new principal. Our $10,857.64 becomes the new principal. We're still going to multiply by the same interest rate. We're still doing 1 year at a time. And this time you get $456.02. You see how it's going up every year? You're getting more and more interest. This is a good thing. If you add the starting balance and the interest, you get the balance at the end of the year. You're going to get $11,313.66, which is our starting balance of the next year. We're getting there. So, got to use this formula again, but the new principal is $11,313.66. Same interest rate. And we're doing 1 year at a time. Multiply that, and your new amount of interest is $475.17. Just keeps going up and up. Add on the starting balance and the interest, your new amount is $11,788.83, which becomes your starting amount for the final year here. So, to do the interest, we have to take that amount, that's your principal this year, multiply it by the same old interest rate 1 year at a time, and this year you get $495 in interest and 13 cents. So you're way above what you were before. You were at $420 up here, now you're $75 more. What did you do differently? Nothing, except use compound interest instead of simple interest. Okay, add that to our starting balance this year, and you end up with $12,283.96. This is our final balance right here. Compare that to up above. Instead of $12,100, you're at $12,283.96. You basically made $284 by doing nothing. except having it in compound interest. Now, if you had even more money in the bank, this would be more dramatic. If you had a high interest rate, this would be even more dramatic. But what would make this really, really dramatic if you left this in the bank for a long period of time? All right, now, if we're doing compound interest, we don't want to have to do year by year by year by year, just like we didn't want to with simple interest. And that's why we could also calculate, remember we calculated this amount here by putting a 5 in there. How are we going to figure this out? Like if I just want this number right here, the highlighted number, how can I figure that out with one formula? Well, you need the compound interest formula. So here it is. A equals P times 1 plus I raised to the t power. Ooh, wow. All right, so we got to go through this and explain some stuff. A, remember what A stands for? A stands for the future value or final amount. So you have to be careful here. Remember when we did the simple interest formula, I'll write it up here again, I equals P times R times T, we found the interest. That formula helped us to find the interest. And then if we wanted to get the final amount, we had to go P plus I, add the principal and the interest. That would give us the A. Now this formula, the compound interest formula, they give you that final amount, that future value, in one step. And that's great if you want the future value. But what if you don't want the future value? What if you want the interest? Well, in order to get the interest, what you would do is you would take the final value and you would subtract the principal. So that's important in this case. Okay, P, just like before, P is principal. The amount of money that you put in the bank or the amount of money you borrow from the bank. I, now this is one weird thing. Remember in our simple interest formula we had P times R times T, and R was the interest rate. Well, now we don't use the R, we use I for the interest rate. Seems a little bit unnecessary to use different letters for the same thing, but that's what we do. And just like before, your interest rate, it must be as a decimal. Got to switch it out of a percent form and into a decimal form. Okay, and the last thing is T, and T stands for time. And again, it must be in years. All right, so let's go back. I'm going to go back to the previous page. Remember that formula. Let's see if we can use that formula to get this number right here, because we really don't want to have to do this when we do the compound interest formula. So the formula was A equals P 1 plus I raised to the T. So what was our principal? That was the initial amount you put in the bank, which was $10,000. Then we go 1 plus I, that's the interest rate. So interest rate, remember, was 4.2%, but we always switched it to 0.042. We took it out of that percent form. And how long did we keep it in there? We kept it in there for 5 years, so we put a 5 in there. So you could do this in your calculator in one go. Make sure you put brackets here, and then you're going to have to use the exponent button. For most of you on your calculator, you're going to see a button that looks like this, or a button that looks like this, or a button that looks like this, or I think sometimes it's like this even, one of those. So you're going to use one of those buttons to do your exponent. That's like a square there. So to do this in my calculator, I'm going to put 10,000, then I'm going to hit open bracket, 1 plus 0.042, close the bracket, and then I want to hit exponent of 5. So my calculator, it's this second button right there. A lot of calculators actually have, I can't remember which one it is. I actually think it's this one for some reason. But one of those buttons, whatever it is, push that one now, then hit 5. And if you do that, I get the answer $12,283.97 when I round. Oh my gosh, what happened? They're different. Well, they're 1 cent different, and the reason for that is just some rounding, because I did rounding all throughout this. So this time we have another $10,000 investment, not very creative of me, but another $10,000 investment. We're going to keep it in longer, 40 years, and the interest rate is 5%. So we're using this blue formula up here, A equals P 1 plus I raised to the T power. We're going to figure out the final amount. P, that's how much you put in, which is 10,000. 1 plus I, that's the interest rate, so 5%. But remember, you got to make that into a decimal. So 5%, you're going to go 5 divided by 100, or you're going to move the decimal, that invisible decimal, over 2 spots. Either way you do it, you get 0.05. And then you're going to raise that to the t, which is time 40. Oh wow, we're leaving it in there a long time. Let's see what our final amount is when we do this. So again, on the calculator, I'm going to go 10,000, open bracket, 1 plus 0.05, close the bracket, raise to, use whatever button you have in your calculator to raise it to something, 40, and I end up with $70,399.89. Pretty well $70,400. That's my final amount. Wait a minute, we started with 10,000, I ended up with 70,000, over $70,000. That's pretty good, right? Wow, very impressive. Now it took 40 years, but remember, you didn't have to do anything to make that money. It just sat there. You didn't even add to it. If you added to it, you get even more money. This shows you the power of compound interesting, how much you can make in compound interest as opposed to simple interest. If you did this with simple interest, you'd have the same P, which is 10,000. You'd have the same interest rate, which is 0.05. Your T would be 40. You'd end up with this much interest, $20,000 in interest. How much interest did we make here? We didn't make this much interest, did we? This was our final amount. How would we figure out the interest? We'd use this formula right here. We'd take our final amount, which is $70,399.89, and we'd subtract our principal, which is 10,000, and you'd get $60,399.89. Look at the difference between the interest you earned here. You earned over $40,000 more. Works out to an extra $1,000 a year on average, just by using compound rather than simple interest. Simple interest, blah. Compound interest, yes. This is so powerful when you're making investments. Okay, how much would you have in your bank account if you could deposit $1 million and leave it for 30 years at an interest rate of 3.5%? This is going to show you why rich people are lucky. It's so easy for them to make money. Just put big amounts of money in the bank and leave it. Compound interest will do the job for you. So A equals P 1 plus I raised to the T. A equals, P is 1 million. Oh, if only could put that in the bank. I, well, we have to change our 3.5% into a decimal, so that's 0.035, and we're leaving it in there for 30 years. So in the calculator, 1 million, open the bracket, 1 plus 0.035, raised to the 30th power. Good Lord, you end up with $2,806,793.71. See what I mean? You did absolutely nothing, and they've made an extra $1.8 million. Oh, just give me $1 million and I'll make enough money for my kids to live on the rest of their lives. Okay, we're going to stop there. I know I have this stuff about the rule of 72 down here. I think this video's gone on long enough. The rule of 72 isn't something I have to teach you. If you're interested, we can do it in class. But today's lesson was about compound interest. We've done that. We're actually going to continue on with it next day because I regret to inform you that this formula right here, it's not the full story. There's actually, this is a simplified version of the compound interest formula. The true formula is just a little bit more complicated. So we'll take a look at that next day. All right, everyone, something to look forward to. Take care. Bye.